In this video we've got a piecewise function and we want to graph it. So you'll notice that we have f of x equals x plus 7. That's going to be a linear equation. And then f of x equals 1/3 x minus 4. That's another linear equation. So what we're going to have on the coordinate system are two lines. First thing I'm going to do is graph the first line. So f of x can be written as y, which will equal x plus 7. Now that's true, and we're going to graph that first here, but we only want it when the x values are less than or equal to 6. So there's a certain domain that we want. But what we can do is graph this on the line first. Our y-intercept is 7. So I go up 1, 2, 3, 4, 5, 6, 7. Plot a point there. And then I use my slope, which is in front of the x. So that's going to be 1, which means I go up 1 over 1. Up 1 over 1. And continue to do that. So I have some dots that I could connect here, or points that I could connect. So there we go. There's my diagonal line. Now I only want that line when the x values are less than or equal to 6. So let's put the cutoff point up there at x equals 6. I'm going to draw a black line. 1, 2, 3, 4, 5, 6. Right here will be 6 for my x values. And I'm going to draw it all the way up so I know where the cutoff point is. And then I'll bring it all the way down this way. So because we want the part of the line that has x values that are less than 6, I'm going to erase everything that is on the right side of this vertical line. Okay, that's the cutoff point. So because x is less than or equal to 6, we want to do a solid dot right there. Because we want to include this value. Okay, now you'll see that this is a line, it follows a domain, so we're good to go. And to help you see this a little bit better, I'll call out all these points, the one right here, 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 and here, and so on, so that you can see that. Now if you look closely at some of these points that I plotted, 6, negative 3, 4, negative 11, 2, 9, all the x values are less than or equal to 6. So that's why I want this side. Alright, now that this one's graphed, let's go down and do my other linear equation. That's going to be y equals 1/3 times x minus 4. So let's plot that on my graph. My y-intercept is negative 4. So I go down to negative 4, plot that. And then use my slope to plot another point. So my slope is in front of the x. It's 1 over 3. So I'm going to go up 1 over 3, plot a point, up 1 over 3, plot another one, up 1 over 3, plot another one, and then I could run that line through those points. Okay, that's as straight as I could get it there. Okay, now I want to erase part of this line because I only want the line when the x values are greater than 6. So here's my x equals 6 line, this big long vertical line, and I want to get rid of everything that is less than, because we want to keep everything that's greater than. So I'm going to get rid of everything that's less than, so it's going to be to the left of it, and then I'm going to keep everything to the right side. Now one other thing I want to check out is the endpoint of this line. Do we want to include 6? No, it's just going to be greater than 6 for x. So we're going to use a open dot there. We don't want to include this x value. And then the last thing that we can do, because we don't need it at all, we could get rid of the black vertical line that we use to help us, set up the domains and whatnot. So this would be your piecewise function. The lines are a little crooked, I think, but hopefully you get the gist of it.